Today we're going to talk about the API security and observability, standardization. Quick intro about ourselves. My name is Mitry. I'm with Discover Financial Services. I'm responsible for the API enablement strategy at Discover. I've been in industry for about 20 or more years. Most recently, I have been focused on the API space. So I started in many roles as Java developer, DevOps, engineer, enterprise architect for a while. But my most recent focus of area is the API standardization. I co-founded the API program at Discover a few years ago. My current passion is about API standardization and enablement. Building an API center for enablement for Discover for all product teams at Discover to standardize their way of working with APIs. We have been doing some cool stuff at Discover. We just filed some patents, that's API-related patents. We always at Discover innovating and trying to be modernizing our technology stack all the time. So it's a great place to work with. And once in a while, I do some posts on LinkedIn. So if you want to look me up on LinkedIn, I would love to get your feedback and we connect there and get your thoughts on this session and any other thoughts that we post there on the conversation. With me, I have John. John, you want to introduce yourself?
Hi, good afternoon, everybody. My name is Coyne, and I'm a software engineer at Discover, where I've been for over 17 years. I've spent most of that time building and architecting job applications in our direct banking area in support of our web and mobile channels.
So what John and I want to talk about today, the agenda for today, we'll be talking about some key challenges that every developer will have to deal with. We know every organization is unique, but there's some common challenges with DevOps, especially with standardization. So we're going to pick on standardizing and picking on security and observability, as you know from the title. And we share why we picked on those two to standardize. And you will walk away with some examples of tools and a frame of reference of how to standardize anything. But we're going to have some inspirational examples on specifically security and observability. But you could apply the learning to anything that you would want to standardize. If we have time toward the end, we'll have some Q&A, or hopefully we'll get some discussions toward the end. If not, John and I will be available outside or in the sponsor area, the booth, Discover booth, right after the talk. So let's look back at the DevOps approach. And historically, why the DevOps was born to start with. The DevOps came about to be able to abolish the walls of throwing over the wall approach, right? The development team will develop something and then throw it over the wall to a build and deploy team, and then they throw it over the wall to run and operate team, right? So in 2006, Amazon CTO came up with Coyne that you build it, you run it mantra, right? To be able to establish that end-to-end ownership of the application or the service. With that established end-to-end ownership, you would be able to measure the performance of the team, the productivity of the team, boost that velocity. At the same time, you would be able to address all the waste, all the choke points that were in the process, having those walls and the handoffs between teams to the next. So the goal is to have that velocity of the team and to be able to address all the choke points with that one end-to-end ownership of that application. Now, another aspect of the DevOps is the size of the team. You know you've got the right size of the team when you can feed that team with two pizzas. I call it the two-pizza team, right? So when you have that, you have high expectations on the team. With a small-sized team, there's something there that needs to be adding up, right? That's what we're going to talk about today. How to measure. And there was a question early on in the morning after the keynote, right, about how do you know that you are getting the payoff of going cloud Kubernetes or going DevOps all the way in? How to measure that? There's many ways to measure that, but there's one way with some of the thought leaders in the industry. They have been standardizing around metrics on how to measure the success of the team. One of those metrics is called the DORA metrics, right? So that small team who build application and run applications, they're expected to deliver fast, software fast. How fast? The lead time metric will tell that's within a day from the moment you commit your code to the deploying that code into production, that's within a day. And how frequent you could do that? It's on demand, right? 2 times a day, 3 times a day, 100 times a day. So on demand, you should be able to commit code, frequently deploy to production with a single-digit rate of failure, change rate of failure. So it's a very high quality while maintaining quality, doing all that while maintaining high quality. And we know that failures would happen. So when failures happen, you need to maintain a mean time to recover from that failure. Any bug fixes or any disruption to the end users will be recovered within the hour. So very high expectations. So this 1-2 pizza team is expected to build the business application and also to learn the tool, the framework, the methodologies of a secure, compliant, highly available, highly reliable application, highly observable application at the same time. With that expanded span of controls, you've got a lot of different cognitive loads on the same team that now need to deliver on all that, on that scale, on that high quality. So there's high expectation. Many teams are falling short of that due to the added complexity and due to the cognitive loads that was added on the team. So what is the cognitive load? There's a cognitive load theory that was studied back in the late 80s. John Sweller was having that definition and the theory of the cognitive load. And basically, the definition from the science book is that the cognitive load is the amount of information processing required by a person to perform a task. Everyone's brain, we have a long-term memory and we have a working memory. If the working memory is overloaded or overworked, the brain function is hampered. And when the brain function is hampered, speed will go down, innovation will go down, and it will cause a high rate of burnout. And it becomes more and more painful to demand more tasks and to demand more performance of that brain that's overloaded. So it leads to a lot of pain. Take a look at this picture. It's a dragon slayer. Imagine a game of a dragon slayer. This is a developer trying to put a new feature to production, right? You can relate to that, right? You can relate very well to that. So in a game of a dragon slayer, a developer will find themselves fighting a dragon at one gate. By the time they slay that dragon, they find themselves fighting another dragon at another gate, and then another dragon at another gate until they get to production, right? The developers, our developers, and many developers, we do have a very high threshold for pain. And many times I hear the statement that developers are lazy. Now, this is not a picture of a lazy person in my mind, but I understand what they're trying to say. But developers tend to develop and adapt to the pain inflicted upon them with taking those shortcuts, right? They have to deal with the pain, with the cognitive load that's increasing more and more. So they have to take those shortcuts. But there must be a better way to go about this. The better way to go about this in Discover, we call it the Runway Initiative at Discover. It started about maybe a year and a half ago. It's a comprehensive, transformative digital journey, excuse me, that's underway in Discover. It's a very exciting time to be working at Discover. There's a lot of aspect to the Runway initiative. You can look it up. If you look up Amir Aruni, the CIO of Discover, who joined Discover almost 2 years ago, you can find a lot of information of what's going on with the digital transformation journey. What I would like to focus on today is what's relevant out of that Runway mission, what's relevant to today's topic, the standardization topic. So one way of dealing with that Dragon Slayer experience is to be able to radically standardize some aspect. I'm going to go investigate which aspect need to be standardized. So one way of working and extreme automation and leading to self-service for developers. Ultimately, we are on a journey to provide that self-service for the developers. So how to really strike that balance between developers' freedom to innovate without stifling innovation and without adding more to the cognitive load, at the same time going fast with high quality and all those metrics that we shared about. So how to standardize? I don't know if you're familiar with the state of DevOps report. The state of DevOps report is a research report that's pretty much tackles and studies many organizations with varying levels of maturity of DevOps practices. And they compare it against each other to see what's working, what's not working. So I like this line from the 2021 report where they say that most highly evolved organizations who have successfully evolved in their DevOps journey have benefited from a top-down enablement of a bottom-up transformation. It's like a paved road from idea to implementation. So it is not like a standardization in the ivory tower approach, and is not also a standardization where you say everything goes full freedom, where you have a lot of different, anarchy, like everybody does whatever they want, right? So it's the top-down enablement of that innovative, and you're going to see how we're going to double-click on that a little bit to see how we can create an environment, that top-down enablement standardization, to create an environment for community-driven solutions and for the teams to excel and to provide for that bottom-up transformation. It's like an express lane for developers, right? If you look at this picture, there is one thing when you go through that express lane versus when you stop to pay for toll, right? The old way of paying toll and then the express lane. This is nice, but think about the number of things that has been standardized and had to work together for this express lane to be efficient and working. Think about the iPass, the EasyPass outlet for sales, right? And then there is the onboarding of that on the vehicle itself, and then the camera installed on the toll plaza, and then the card on file for the driver to have a card on, and then the payment processing behind the scene, and all that working together for the express lane, like a simple act of just paying toll in an express lane, right? If we were to do that in a software industry, if we were to do meet all those high expectations of a DevOps team with that control and all those metrics, we have to put together those standardization and foundational components that need to work together to allow for that paved road for innovation, or paved road enablement of top-down enablement for the developers to innovate. So with this, there's a standardization blueprint, a high-level reference architecture, where you gotta start from the design time all the way to the runtime. And with that, we're establishing some very clear planes where you have the experience plane, the management plane is a headless API management plane, and then you've got a control plane, which is like a global, universal to the whole enterprise, and you have a control plane that's specific to a specific cloud or a specific on-prem or a specific platform, the target platform, until you get your runtime. So in the experience plane, you've got all the launch pad of developer experience, all the self-services, the common navigation. You've got the dashboards for those developers to anything they need to know on that experience. The search, discoverability of API, discoverability of code pattern, discoverability of solutions or tools that's becoming more and more the standard for the company. Some social features, like you try to follow an API, or you follow a person, or you follow a product, so you get notified. So that's the experience plane. Now, on the management plane, that's where you have all the knowledge of where the systems of records are, the portfolio management, the change management, all that cognitive load that would be imposed on the developer is abstracted away from the developer experience plane and pushed down to that management plane. So you've got the ability to establish single source of truth for the developers. So they don't have to be, the developers don't have to run around and depending on their network, who do you know in the company to be able to develop something fast. That all the single source of truth will be managed and fed within that management plane. And then you've got the control plane. We have a standard pipeline where you start to put all the universal policies, the enterprise policies there, security scans, everything that the developer would get for free. You would put it in there. And then you've got the platform-specific component, and until you get your business application or infrastructure. And we'll double-click on that for the examples of security and observability and how we apply this blueprint to standardize anything, which would be now, in our example, security and observability. What to standardize is as important as to how to standardize. So if we alleviate those 4 things that we listed here on the left-hand side, if you alleviate those, you have removed a huge burden on the developer's shoulder. So what to pick and what to standardize would be asking the question, what are the aspects that are most burdensome on the developer? And you see onboarding, security, documentation, and observability. Those are becoming more and more complex, more and more adding to the cognitive load. So, and developers are not the expert builders for that. They are the expert users of that, but not the providers of that. So it would be a good place to start, to standardize. So double-clicking a little bit on onboarding. Usually onboarding is a painful task for developers, right? Like we had to create a new component, a new namespace, a new API, and there's many systems you have to deal with. And you have to learn each of these systems, their process, their silos, right? So that's where the experience plane, establishing the experience plane and the management plane and the control plane would be very helpful. So the challenge here is to how to still govern, still be compliant, and all that without adding that cognitive load, without missing out on feeding the systems of record of what the developer is doing. And how to identify the opportunities. We were talking about that earlier, that's how to identify, having those discussions that are missing on, do we really need to build this? Maybe you already have it somewhere in the company that you could reuse. So the onboarding process becomes challenging in that manner, that it has to deal with a lot of different unrelated systems and unrelated conversations. So how we tackle that in that blueprint. So this is one way of applying that blueprint or the full circle that we've been talking about. It always starts with the experience plane. So having a developer portal, here we call it the API, but usually it's a developer portal, a more expanded role of that portal, or a CLI kind of interface within the experience plane. Now in the management plane, it knows where to go. So everything that the developer needs to know would be on that experience plane. Consolidated would be all under that experience plane, so the cognitive load is addressed. And then the management plane that we're establishing, we have a small management plane that's growing right now to be able to know what management portfolio system to feed, what change management ticket need to be opened, what the governance process would be. So the orchestration happens there. Until you get to the declarative configuration, the output of that management plane is some manifest files or specs that the control plane can rely on to provision to the runtime. So you go and you do provisioning for that based on the policies that were designed by that management plane. Moving on to the security, API security is one of the top concerns for security professionals these days, right? It's an open attack surface when you could access backend systems through their APIs. You cannot protect what you don't know it exists, right? So you've got to have a list of inventory of those surfaces that are exposing the technical or the business capability to the world or to each other within the company. And once you have that inventory, each of this API, all API traffic must be authenticated, authorized, being able to audit it. So AAA security on all API traffic. That's another challenge of API security. An additional challenge is the misconfiguration of security. This is one of the, I think it's the top one or top two on maybe the second one now. To misconfigure security, so unintentionally opening something that you're not supposed to open. That's one of the top on the list. So how we tackle all that, keeping up with all the different threats and moving target with security, while the developers are not the experts on security, they are the users of that, and how to keep up with all that. So again, going back to the blueprint, it starts with the experience plane. There are some components on each of these planes that work together, are stitched together to apply, to take away the security configuration out of the deployment or like development and deploy, right? And also being able to get to the inventory of the APIs, all APIs, and having all the, so here, if you request access to an API, you go to the API access interface, like the headless interface, which will create the right tickets and will do behind the scene, feeding the right system, API access management system, all the different backend systems that need to happen. And then it will also provision the specs, the security policy, because every API is locked down, is born with, is already secured. So now the new consumer expected, now you need that policy to be out there, and you also need the credentials to be out there. So security policies as well as the credentials are both need to be provisioned at that time. And John will show us some examples of how that is all working together. And this is an example in the control plane on how some of the community solutions came up to do the auto-config. John is also going to show us that auto-config within the Spring Boot, how to auto-config some of the security. And then finally, within the runtime plane, we've got an embedded validation, the security enforcement. So all that validation is handled within that module that developers will include in their application. And we have a sidecar pattern. It's also John going to show. With that sidecar pattern, it's all the secret handling is been taken care of outside of that deployment. So if you go through this once, now anytime you're deploying your application or all the developments, the sidecar is injected all the time during the build time, and that will handle all the secrets for you in production. With that, we'll turn it over to John to walk us through some of the other examples.
All right. So while George has presented some challenges and conceptual solutions, I'm going to walk through some of the details on how we're implementing those at an enterprise level. So the first step in building a new API is first determine if you really need to build it in the first place. Maybe something already exists. Having a centralized API portal to discover, consume, create, and manage APIs is crucial to maintain a healthy internal API ecosystem. Whether it's something that you build on your own, a vendor product, or a combination of the two like we do. When you decide that you need to create an API, having a portal where you can register it with the attributes such as obvious ones of what the API does, what information it provides, and then diving into more non-functionals, such as what availability class do you want, 3 nines, 4 nines, what sort of data classification are you handling? This is important to make sure that all your consumers can discover and consume it and understand their own availability goals. Also things like API scopes. Do I want to offer read-only access to my API in addition to a full access? So submission into the portal can then trigger some creation into downstream systems, such as a portfolio management tool or creating a new repository in GitHub. Another process that can be triggered is registration into the API or a headless portal that George talked about earlier. This can generate your API security keys. Additionally, we can insert all of the non-sensitive data into GitHub as a system of record. And then we could trigger a Jenkins pipeline to then load that data into Vault, where it will then be used as part of the runtime plane. So at Discover, we've recently created a new enterprise declarative pipeline, sort of at the enterprise level. In our first journey to cloud, there was a lot of different, sects of the company where they were building their own pipelines. We kind of decided at an enterprise level we need to have a standardized golden path, if you will. So this relies on a number of different configuration files that I need to add, and then I can take advantage of this enterprise pipeline by reference that's powered by Jenkins and Kubernetes. The configuration that drives the pipeline is broken down in different concerns, which I'll talk a little details about. The first is the inventory config. This contains basic data about your application, your product team that supports it. For example, what is the Jira ticket prefix that you use, and what is a webhook URL you want notifications sent to? The build configuration defines how to build your application and how to version it. For example, what version of JDK do I want to use, and do I want to use calendar or semantic versioning? The test plan defines the different types of tests I have and how to execute them. For example, do I want to run a simple test on Jenkins with Gradle, or do I want to deploy a pod to Kubernetes as a test runner? The deployment configuration defines all the different environments that I have, along with where and how to deploy them. And what kind of deployment strategy do I want to use? Is it a simple rolling update? Do I want to use blue-green or a canary? Lastly, the promotion configuration defines what environments and associated test suites that I need to successfully run before I can consider my artifact as a release candidate. Now off to the right here is a picture of what our enterprise pipeline is, and I'm not going to go into all the details, but I do want to highlight 3 important steps that occur that are enforced by the pipeline. Those are a static code analysis, open source vulnerability software scanning, and interactive application security testing. These are crucial security steps. And along each step of the pipeline, including the testing, all the evidence is uploaded to a centralized repository where it can then be downloaded and viewed through what we refer to as a release fitness report. So this is important both for developers and product owners to be able to see the status of a particular version of an artifact. By applying all of my Jira ticket IDs to commits and pull requests, we can see all of the requirements that are part of this release, in addition to all of the security scans and the test results. This enables quick debugging in the event of issues. I know where to go download my test results and check out what's happening. I'm going to walk through some of the libraries and processes that were built as part of the paved road to make building and deploying an application as smooth as possible for developers. To make securing and consuming APIs as simple as possible, we have an internal Spring Boot configuration library that just makes it quite simple to add a Gradle dependency, and then just define, am I an API provider, a consumer, or both? This will take care of then wiring up all the necessary beans to protect my API and consume APIs. The rest of the configuration will be provided externally, which we'll talk about a little bit when we read it from Vault. So to deploy an application to Kubernetes, our platform team has created a number of different Helm charts that simplifies it. I'm sure as anybody who knows, that learning Kubernetes YAML is not the most straightforward thing. So we use several different Helm charts. For example, if you're deploying a Spring Boot application, there's a specific Helm chart for that. One of the specific sections in there is the ability to define a Vault section where you give those paths that were inserted by the API management process earlier, and it'll take care of mounting those for you and injecting them into the environment. This is powerful as it standardizes and abstracts away the finer security details for developers to allow them to focus on building good products. So the process to inject the secrets in the configuration involves deploying a new pod to Kubernetes, and then a sidecar container using the service accounts token is able to access Vault using Kubernetes authentication, and then it will write those secrets to an ephemeral volume within the pod. The application then, on initialization, will read those secrets and wire up the necessary beans. And then while the application is running, a sidecar will kind of pull for updates to those secrets. And if it does see an update made to Vault, it can either trigger a rolling update to the deployment, or if the application is enabled, it can invoke a Spring Boot actuator to go ahead and refresh those beans. So once the application is up and running, the access from an API consumer to provider looks something like this. Using the secrets that it obtained from Vault and the SDK, the client will go ahead and reach out to the API management system to obtain a JSON Web Token, JWT, or JOT, however you refer to it. And within there are the claims of the consumer identity and the API scopes that it can access. The client would then present this token to the provider, and then using an embedded gateway SDK and the public certificate obtained from the management server, the provider would validate the token and then pass the request on to the API. Now, an important point I want to show here is this is an embedded gateway. Unlike a traditional API gateway, which sits in between a client and a server, this is embedded and it reduces some of the overhead and complexity with maintaining a gateway. It also takes care of a security concern of what they call the last mile in between a gateway and a provider. So the security is embedded right into the provider. All right, so now that I've kind of touched on some security solutions, I'm going to turn it back over to George to discuss some observability and documentation concerns.
Thanks, John. Security stuff are fun, right? So now that's fun until it's kind of taken care of, right? Now moving on to the documentation, we take a design-first approach for our APIs. A design-first approach means that you specs-first approach. If you remember the API portal screen, illustrative screen, you first start with the design-first attributes, or you upload your specs to do some maybe linting, to do some, the right discussion, shift left as possible, right? So we think about the specs as the common language that all the planes can now speak. Once you've got the specs committed to, we know this is the specs. Now, you could get the specs out to different teams, and every team will take that, can have certain policies based on that specs, security policies. You've got like networking policies, you've got some automation, you got some business logic. So all the different concerns or control planes or management planes, all those will be fed with that common language. The problem with going with code first is that it's uncommitted specs. It might lead to some wasteful effort and also bloated interface that wasn't really discussed in a proper context. And it also could be leading to bottlenecks when one team has to finish, then the next like throw it over the wall again. And I think with Kubernetes and the cloud movement there's a lot of emphasis on the declarative model. Now we have, as developers, we have the tools to go with that declarative model. Based on that specs and the manifest files, we provision a whole data center, if you will, right? And all security policies and all based on that set of specs and manifests, right? So that's the approach. Now with observability, it's becoming more and more complex. With highly distributed services and microservices, observability becomes non-negotiable. You gotta know, do we have a problem to start with? Without proper observability, you don't even know if you are having a problem. And if we are having a problem, how to measure the mean time to recovery? Are we recovering fast enough, or are we recovering at all, right? And as a consumer of an API with those multi-layers of services, I cannot tell if this API will meet my SLA requirements. I don't want to find that out later on, and after I go to production, I see it's performance issues, and I don't know where that is coming from. So we want to intentionally shift left those conversations, observability conversations, becoming more and more important to miss and to become an afterthought. We have to allow for that in the standardization blueprint, starting from the experience all the way to the runtime. So we think about, this is just one example. Observability there's a lot of talks in this conference about observability that I really learned a lot. But I think this one is just as an example of how to standardize certain metric, the SLO metric on observability. So starting from the experience plane, an API provider will provide what's their target service level objective, the SLO. And they will define availability class, whether 3 nines, 5 nines, or best effort availability, right? And then also one of the taxonomy elements there is the a URL for the enterprise dashboard, monitoring dashboard for that API to show, right? So once I get that this is collecting all what the developers need to provide, like as shift left as possible, driving the right discussion at the right time, and consolidating in the experience plane. Now, the control plane will get it and will produce that. So the management plane will get it, will produce declarative SLO, and John will show us how that could look like in a open API specs. Declarative SLO, where we can now provision and deploy with a built-in observability already enabled for that API for everyone. Now on the runtime, all this application will be talking to the enterprise monitoring tool, which in turn can now, because we do have that URL that was provided initially, now we can show that back to the API consumer to be able to view that dashboard, understand what's going on, the objectives versus the actual numbers. And if you want to subscribe to some of those alerts. So based on that specs that was produced, you could pretty much have built-in policies to, if I'm not meeting those objectives, I will be alerting the right person and the right people. And that all started from consolidating all this information from the experience plane to provide it once and be managed through the rest of the control planes and the runtime plane. With that, we'll turn back to John to show us the cool stuff.
All right. So to standardize and simplify API documentation for developers, we've created another internal Spring Boot auto configuration library to make it as easy as possible for a developer to start documenting their code. So the Open API specification, formerly known as Swagger, which I'm sure a lot of people are familiar with and use, allows you to write your documentation right alongside your code. There's a Gradle plugin that makes it available to actually generate the JSON spec during the build process, which we could then use to upload to the API portal to ensure that as the code changes, it's staying up to date in the portal. Something else I want to point out is that the Open API spec has an extensions property that allows for defining custom fields. In this example, I provided one called service level objective, where I provided my latency SLO of 3 seconds. We could then use this information in the pipeline to display in the portal, but also we can use it to generate monitoring alerts and dashboards based on that value. Our platform team has created a Kubernetes resource for creating alerts in our performance monitoring tool in Stana. So using that information that we had before, we can generate some configuration that allows us to then generate those alerts as part of the pipeline. Here I have an example of the error rate and the latency. Also, we can generate monitoring dashboards using those service level objectives. This will let us know what is the current state. Are we achieving our objectives? In this example on the left, I can see my target availability goal is 99% for this method, and I'm currently at 99.91% based on the errors that have occurred during the selected time period. Another useful tool that I'm sure many here are familiar with is Micrometer. Micrometer is a vendor-neutral applications metrics facade that provides metrics to be consumed in any number of different performance monitoring tools. It provides a lot of useful metrics in regards to latency, throughput, error rate, JVM metrics, connection pool values. There's the ability to create and export custom metrics as well. Here I've listed the 3 types of metrics it has: gauges, counters, and timers. And the way that these are pulled into tools is either through a pull or a push method. So I know Prometheus is a popular open source one that does a pull, but that presents challenges because if you have a clustered environment that's behind a router, or you can't ensure which instance you're reaching, as well as security concerns with exposing that over a web endpoint. So the more popular method is a push method, and Micrometer has different hooks with different performance monitoring vendors. Or if you want to do it in a more agnostic way like we're doing, is just use JMX. So you can actually add in a JMX dependency. And here I have just a simple example of a counter metric. So as I previously mentioned, we have an embedded gateway and not one that's sitting in between a consumer and provider. So maybe we want to track the requests broken out by the consumer, right? So in our gateway, we could decode the token, find out who the consumer is, and then just create a simple counter. So if I added this, I could then use the JMX dependency, fire up Jconf on my laptop, and then kind of see, okay, here's the metric. I'm able to view it. And then once I deploy to an environment with a monitoring tool, I should then be able to build a dashboard based on that. And typically with counters, they infinitely count, but you want to view like the rate at which the count is occurring. So you create a dashboard, and now you can see by consumer who's calling this API. One last tool I want to discuss here is Gatling, which is a load testing framework where you can write tests in either Java or Scala, and then execute with a simple Gradle task or a provided shell script from the framework. We have a custom container image that makes running Gatling tests as part of your pipeline as simple as possible. The developer just has to simply specify in their test plan, I have a Gatling test. Pipeline will take care of provisioning a pod in Kubernetes, cloning their Git repository, copying the resources and test files, running the tests, and then uploading that evidence to the repository. The one thing that we want to kind of start enforcing soon here is the assertion of service level objectives. Similar to a unit test, we can make sure that our load test is meeting our service level objectives, and if not, we won't promote it to a release candidate. All right, so to wrap things up, I just want to kind of highlight a few key points. Promoting radical standardization to help achieve your goals. Let your developers focus on building the important things. Rally support for top-down enablement of bottom-up transformation. Having a paved road is key to extreme automation. Remember that what to standardize is just as important as how to standardize it. Try to reduce the cognitive load on developers. And lastly, leverage a declarative model that's opinionated but flexible. The tools are important, but they should be able to be swapped out or replaced easily. And with that, thank you.